Okay, so let's solve this question. The question states that consider the following deterministic finite automaton, right? Deterministic finite automaton defined over the alphabet A comma B. Okay, this is the alphabet that is present for this particular machine, and throughout this question, wherever this kind of machine, this kind of language is being considered. Okay, identify which one of the following languages is R. So this means this is a MSQ type question, multiple select question, multiple choices can be correct, and there is no negative marking, so we have to attempt it no matter what, right? Accepted by the given DFA. So there are, which of these languages are accepted by this particular DFA, right? So first of all, let me make this very clear. A particular machine accepts only one single language. This is our concept over here now, is kind of deceiving, is kind of a bit not very straight, right? Why? Because this is a theory of kind of your machine in computer science. A machine, suppose M1, accepts the language L1, right? And L1 would have a certain set of strings, right? If the alphabet is basically A comma B, right, and the language is basically going to have ABA and BAA and so on and so forth, right? This kind of patterns are present inside of the language. Very good. Now suppose that another language L2 is going to be a proper subset of L1, right? Suppose that is the case, and L2 is basically equals to your ABA. This particular instantiation of L2 and L1 is basically holding with the fact that L2 is going to be a subset of L1 because the elements of L2 are also present in L1, right? Once that part is very clear, now I want to state to you something. The string of L2 is going to be accepted by the machine. That part is correct. This is going to be accepted. But this whole language is not going to be accepted by the machine. It's not going to be accepted. Why is that? Because for a machine to accept a language, it is kind of a holistic mechanism. Every single element that the machine can accept must be present in the language. So it is not that just every string of the language must be accepted. It's that every possible string that the machine accepts must be present inside of the language, right? And hence, if there were to be L1 that is accepted by the machine and L3 is also accepted by the machine, that would directly imply that L1 is basically equal to L3, right? That is a fundamental concept in theory of computer science, right? So I hope that you are able to understand it. Just because every single string that is present inside of your language is accepted by the machine does not mean that your language is accepted by the machine. For that to be true, there must not exist any other string outside of your own language that would be accepted by the machine, right? There's two aspects. Every string in your language must be accepted, and there must not exist any other string outside of your language that would be accepted by the machine for that language to be accepted by that machine, right? I hope that this part is very clear to you. Now let's go back over here, right? Now let's read the options that are given. This is our concept, that is why it's not correct, because a particular machine accepts only one kind of language. Till that particular language is not if two of these options are correct, then both of those options would have to be the same, just addressed in a different manner by use of wordplay, right? That's something that should be very clear to your mind, right? There are no multiple languages that are accepted by the machine, right? The first option states a set of all strings containing an even number of B's, right? Okay, so I can check it with all sets of B's, but because when I look at this DFA, there is a B that can occur any number of times, right? And this B occurs at the path, in the path of the shortest possible string that is accepted by that machine, right? To consider any machine in a very systematic manner, start with the shortest possible string that is accepted by the particular machine, right? And that is BAB. And in the path of BAB, any number of B's can be introduced, right? BAB in and of itself has two number of B's, okay. But if I were to introduce another B right over here, what will that give us? BBAB. And this has three number of B's, and that is odd number of B's. So this particular option is not correct, right? That even number of B's can only be possible. That is not correct, because a string exists out of the language that this particular option gives, right? Set of all even number of B's, there exists a particular string, namely BAB, outside of this language, which is also accepted by the machine, and hence this is not the language which is accepted by the machine. This option is not correct. The second one states a set of all strings containing the pattern BAB, right, to the set of all string that contains the pattern BAB. Okay, if you were to start from B and then A, and okay, let me just first clear it out a bit so that we can do the analysis in more clean manner, right? So it is stating that that all strings containing the pattern BAB is going to be present, right? Okay, so the shortest string does have BAB, that part is correct. If I were to consider the deviations, right, if I were to introduce a deviation at the starting, right, any number of A's that I introduce at the starting and then BAB is introduced does not really hamper the existence of BAB. If I were to introduce any number of B's over here, right, BB, right, that is also not going to hamper the existence of BAB. Okay, if I were to introduce this pattern back over here, so it is coming like BAB and then this AB, right? So BAB is still not hampered. Okay, if I were to go along like this, what will this produce? This will produce BAB, then BAB, right? This will also produce, this particular deviation will also not hamper the existence of BAB present, right? If I were to go along from this, it is going to go at the starting, and from the starting state, BAB is going to be present only. There is no hiding from that fact. So yes, the string, the patterns that are accepted by the string does indeed have BAB. But now come back, be very clear on this. When you read all strings now, right, all strings containing BAB, right, so be very alert on this one, because this all string, when it states now, so there could be possibilities which are not present over here, right? And what are the possibility over here, right? From a semantic point of view, a particular string can exist at the starting of all possible strings, right? BAB could come at the start, could come at the middle, could come at the end, right? This is analysis of strings that you must have played with, that gives you this semantic classification, right? So if I were to consider it, if you were to consider it like this now, so in this systematic manner, then you can generate in your mind from the starting point of view a pattern like BABAAA, right? This kind of pattern is going to be present inside of this language, right? The set of all strings containing the pattern BAB, right? This kind of pattern is present inside of this language, but this kind of pattern would not be accepted by this machine. Why? If I were to go like this, BAB and then A, one A goes here, one A goes here, and then A's are basically fed over here, and then we reach at this state, and this is not the end state, right? So this particular string is not going to be accepted by the machine, but it is present in the language. So because acceptance by a particular machine of a language is a holistic scenario, so every single string present in the language must be accepted, right? And there must not be any string outside of the language, both of those things, right? So acceptance of the strings present in the language is not present, hence the option B is not really correct. If I were to look at the third option, it states that set of all strings ending with the pattern BAB, right? As I looked over here, if I were to do any deviation from the end state, it again produces BAB at the end, right? As I basically did over here, BAB, right? It's very simple and it's very straightforward, right? At the end part, this particular machine does accept BAB, right? This, if you're not able to follow this thing, just rewind a bit when I was explaining the set for BAB being present, right? Because if the BAB is present at the end, it is going to be present in every single string. That is correct, but it does not, is not present in all strings. That is the thing which the second option missed, and the third option has. So the third option is correct. Now let's read the fourth one. Now, because third option is correct, the fourth one either has to be some kind of wordplay that is causing the same language as C, or it would not be accepted, right? The set of all strings not containing the pattern ABA, completely different. So this is not really possible. This is not really correct. ABA would not be the correct answer. One thing that I would go along with is basically show that this is not the case, so that you have better confidence in what you are doing, right? ABA. So is there a possibility of a particular string that contains ABA? Yeah, right, it is present right over here. I don't even need to do that. It is present in this string which is accepted, right? ABA is present, and it states that the set of all strings not containing ABA, while BABAB is accepted by the machine, and hence this fourth option cannot possibly be correct, right? It's extremely simple, but obviously you need practice and you need very crystal clear concepts, right? and I hope that you must have been able to solve it by yourself, and this video only serves as validation for your own solution. And with that, have a very good day. I will see you in the next video.